On September 28th of 2023, Amazon Bedrock was publicly announced as GA. And since then, there was a lot of excitement in the generative AI industry because this service is pretty awesome. It allows you to work with different large language model providers via a single API. However, as a Java developer, you may look to this and say, yeah, this is great, but I'm pretty sure that this will never be available for Java, right? Well, I'm here today to say that this is simply not true. Amazon Bedrock provides full support for Java and other programming languages besides Python. In this video, I will show you how to get started with the service using the AWS SDK for Java. And I will show this in the best way developers like to learn things, via hands-on examples. Hi, my name is Ricardo Ferreira, and I'm a developer advocate here with AWS. As a long-time Java developer, I've always felt a little thrown off about my ability to work with technologies such as generative AI that became mainstream using Python technologies. My feeling was like I didn't belong to that world. But one of the bad things about the services offered by AWS is the fact that there is a support for multiple platforms and programming languages. And with Amazon Bedrock, this is no exception. In this video, I will walk you through in creating 3 different examples. They will provide you with the proper knowledge about which dependencies to add to your project, how the SDK for Amazon Bedrock works, and how to interact with the service via different programming modules. The first thing you gotta do to start working with the Amazon Bedrock with Java is to add the proper dependencies. So if you are using Maven, you can go to your pom.xml file and add these 2 dependencies here. The first one is going to be the Bedrock, and then the second one is going to be the Bedrock runtime, right? Always make sure to use the latest versions of the SDK so you can leverage all the security patches and the new features that has been introduced. So with that said, let's go to our first example. The first example is going to use the foundation model called A121 Labs. This foundation model is going to be responsible for reading this contract here that we're going to provide as a prompt. And we're going to ask it to extract the band name from this contract, right? So as you may know, the machine doesn't know this yet, but you and me, we know that the band name is going to be called Good Kid, but we're going to ask the foundation model to figure that out. How are we going to start this implementation? So the first thing you got to do is to create something called a Bedrock runtime client. How do you create this? You're going to use this try finally block, and then you are going to use this interface here, Bedrock runtime client. Let's call Bedrock client for the sake of simplicity. And then you can use the builder interface to start creating this object. So you can call the builder, and then you can simply build from this object. There are a couple parameters that are mandatory for this to work. As you may expect, this client is going to establish a connection with AWS. So there are 2 things that you have to provide. Number 1, what is the region that for the service that you are invoking? So in my case, I'm going to choose here US is 1, and I'm going to also provide the credentials provider, right? So why this is important? Because ultimately you are going to establish a connection with the service. So you have to authenticate with AWS. I have actually my profile, my credentials from AWS stored on my machine. Was the result of when I used the CLI, I type it AWS configure, and then it was stored on my machine. So what I can do is to use the profile credentials provider, and then I'm going to simply invoke create, right? I could, if you have multiple profiles stored on your machine, you can specify the profile name here with this overloaded version of the constructor, but I'm going to use the default, so that's more than enough, right? So with that said, the second thing you got to do is to create a request payload. So Amazon Bedrock is an API, and it expects you to provide a payload that's going to contain the information that is going to process, right? So the payload you can create using a simple string. So you can call the Bedrock body. And then we're going to use a utility class that is provided in this project that you're going to use called Bedrock request body. There is a builder interface that is going to help you to create this this payload for you. So the first parameter you have to provide is the model ID, which is going to provide it here on this constant here called model ID. And then the second one is the actual prompt. So you have to provide which prompt you are going to use. With that, you can simply build the request. So with the model and the prompt created, now we're going to assemble our request, right? So the request is going to be called the invoke model request. That's a good name. And then we're going to create a new instance of the invoke model request using the builder interface. So with the builder interface, you have to also specify the model ID. So I'm going to use the constant that we've used it before. I'm going to reuse the same constant. And then you also have to provide the body of this request. So mind that the body of this request expects you to provide this body in this format called SDK bytes. So we can use actually the SDK bytes utility function called from UTF-8 string. So we can reuse that request body that we created before. And then we can simply do the build process. So with the request properly created, we're going to finally invoke the Bedrock client. So we're going to call Bedrock client, and then we're going to call the operation invoke model, providing our invoke model request. The result of this operation is the actual response coming from Amazon Bedrock, which is going to provide you a invoke model response, right? So we can use the same variables here, use the name convention, and then this response is actually going to come up in the JSON format. So we can use we can create here the response as JSON, and then we're going to simply instantiate a new JSON object here out of the response that's coming from the Amazon Bedrock. So we're going to get the response, read the body, and read as a string UTF-8. Right, so this is going to be a JSON payload for the sake of the argument. Let's just fix here. We forgot to instantiate the object, so new JSON object. Now let's print this object for the sake of the argument so we can actually see the content of this first JSON payload. So I'm going to execute the first time here, and let's see how this JSON payload looks like. So as you can see here, this is the response. It is for this particular foundation model, is a very dense and slightly complicated JSON structure that you have to transverse, right? So always keep in mind that each foundation model has their own structure for response. So not all responses are going to be the same. That means that if you change the foundation model, you have to keep in mind that how you are going to parse this JSON object that's coming as a return is going to be different. So what I'm going to do is to use a very unique to A121 Labs way to parse the response. So I'm going to use this approach here. So as you can see here, I'm reading from the JSON payload. I'm going to read this JSON array called completions. I'm going to retrieve the first entry of this array, and then I'm going to retrieve an inner object called data. And within this data object, I'm going to read the text attribute. So basically, I am navigating within the JSON structure. So let's execute this program one more time so we can see the results of the response. So let's see if the A121 Labs foundation model is able to figure out the response. And it seems that it is. So the response is good kid. So that is the proof that our Java program was able to invoke the Amazon Bedrock API using the A121 Labs as the foundation model. Now let's start developing our second example that is going to be similar in terms of programming style that we have just did, but we're going to use another foundation model from Anthropic that's called Claude V2. But not only the foundation model is going to be different, but the example is going to be slightly different as well. For this version, we're going to provide this rather complicated description of what is generative AI, right? And then our prompt is going to be, please create a single short paragraph that even a 5-year-old child can understand. So we're going to ask the foundation model to simplify a lot this description, right? So for the sake of the programming style, I'm going to actually reuse a lot of what we have done from the AI21 Labs example. So I'm basically copy and paste the same code that we have created there, because the programming style is going to be exactly the same. The same objects can be created all over again. The only difference is how we are going to parse. I'm going to actually remove this. We're going to parse the response in JSON that will come from Anthropic Claude V2, right? So, but as you can see here, everything else remains the same. We're going to create a Bedrock runtime client, specify the region, credentials. We're going to create our body, and then we're going to assemble a invoke model request, providing the same model. We're going to provide the body as in the format of SDK bytes, build it, invoke the model, get a response, and extract the JSON payload out of that response. Before actually parsing that, let's take a look on this JSON payload real quick before we actually start parsing the JSON. So I'm going to simply print the JSON payload as is, so we can take a look on the response. So just to recap the example, given this large description of generative AI, give me a 5-year-old description of it. So I'm going to execute this code, and let's take a look on the JSON payload with the response. Alrighty, it should be coming back pretty soon. One of the characteristics of this programming model here is that it is blocking and synchronous. So as you can see here, it took a little while to execute, but here's the response. So it's a rather simpler JSON payload that has one attribute called completion, and within the completion, here's the response, right? I'm not gonna read it right now. So let's just parse the JSON payload. But as I was saying, this style of programming is called synchronous and blocking, because this execution of the invoke model is going to block, right, and wait for the response. And then this may be fast or take a while. It depends on a lot of factors, including the network latency, how busy are the regions, and et cetera, et cetera. So in the next example, I'm going to show you an alternative approach to solve that problem. But for now, let's just finishing the parsing of this JSON payload. So for this example, we need to simply read the completion attribute. So that's what I'm going to do right here. I am going to basically read the string called completion. So let's execute this code one more time to see the result. So let's see how would be the description of generative AI for a 5-year-old to understand. All right, the results should be coming soon. And then once it comes, we're gonna read it. Here you go. So generative AI is a type of a computer program that can make things all by itself. It's like how people can come up with new ideas and create new stories. So yeah, that's a very compelling way to explain things for a 5-year-old. So it seems that it worked, and our interaction with Amazon Bedrock once again was established and successfully executed. Now let's take a look in our third and last example, which is going to be a variation of what we just did, but we're going to use something called the streaming API. So what is the streaming API? We're going to actually not necessarily wait for the overall response to be completed so we can start printing the output. So we've established the connection with Amazon Bedrock, and as the response is being generated by the foundation model, we're going to capture in a streaming way, chunk by chunk, and then we can start printing a result. Almost as if we were like interacting with the foundation model in one of those chats where you are interacting with the artificial intelligence, and they kind of start printing all the letters in a like continuous sequence, but not at once, right? So the example is going to be the same. Given the large description of what is generative AI, we're going to provide a 5-year-old description, but you're going to see that the programming model is going to be slightly different. The first difference is going to be that we're going to do this, execute this code, and we're going to spin up a thread, right? And because of this, we need to control when the programs finally execute. So we're going to create a countdown latch right? For Java developers are familiar with this. This is how you can make sure that the program is not going to finish once it's going to wait all the spawn threads to finish their work so the JVM can actually finish. So with that, we're going to actually create the same Bedrock client just like we did before, with one difference. Instead of creating a Bedrock runtime client, we're going to create a Bedrock async client. Bedrock runtime async client, to be precise. We can also call Bedrock client for the sake of the matter, but we're going to use this variation of the Bedrock client that is going to be, as the name implies, asynchronous. So we're going to build it. And just like the synchronous version, we have to provide the region and the credentials provider. So this is Amazon Code Whisperer that just learned my programming style and my intention and is trying to help me to complete. And it was spot on because this is what I need. I just need to import this region for me right now. So let's do this. Okay, re-import, that's it. Okay. Come on. Okay, let's do it in the command line. So let's do this, just import it. And then once you do this, what I'm going to do, I'm going to create a thread. And since I'm using Java 21 here, I'm going to actually use a virtual thread that is, as probably you are aware of at this point, Java 21 includes Project Loon, so we can start instantiating like virtual threads. So I am going to actually create this using a executor. So the programming style is actually quite simple. I'm going to actually create an executor, and then from the executors, I am going to create a new virtual thread task executor. So that's going to be our programming model. And then for this executor, I'm going to actually submit a runnable task, right? So this runnable task we're going to provide as a Lambda function like this to simplify the programming model. And then everything else after this is going to happen. Once we actually provide this, we're going to ask the countdown latch to wait. And what it's going to do is going to aid everything that's going to happen in between this implementation to finish. Then it's going to actually finish the JVM. So that's going to be our approach. Once we do this, what we have to do is actually assemble the body of our invocation. So it's very similar to what we have done before, with the slightly difference that in this case, and just for the sake of illustration, I'm going to also calibrate our inference. Inference is the process that we call for the foundation model to actually provide a more spot on and accurate response. So you can actually calibrate the maximum tokens to sample, the temperature, top K, top P. Those are parameters that are going to be unique for each foundation model, and you can always refer to their own documentation to understand what they mean, right? So, but the point is that you can use those inference parameters here while assembling the request body. So now that we have the request body, I'm going to create a invoke model with the streaming request. Now note that different from what we have done before, in the previous examples, we have used this construct called invoke model request. That is the synchronous version of the API. If you plan to use the streaming API, you have to create an invoke model with response stream request. The programming model is similar. You're going to use the builder, set the model, set the body, and you're going to build. The only difference is that when you invoke the Bedrock client, that I'm going to do actually right now, Bedrock client, and then invoke model, you are going to use this version here called invoke model with response stream. So I'm going to use this part, and then this is going to be our request. And for now, I'm going to simply provide no, so you can see the difference. Before I actually continue the implementation, let me explain this. This is going to be a asynchronous invocation, so there is no need for you to actually read the response. There is actually an object that is returning from here. You can actually read it. It's going to be a completable feature. that you can use to follow up the execution of whatever is happening on the back end. But the actual way that you are going to use to process the response is providing a callback, right? So how you are going to create this callback, you are going to use this callback handler builder here that I'm going to show you now. So I'm going to actually copy all of this so we can provide the complete example for you. I'm going to copy here, and then I'm going to paste so you can see the implementation. All right, so let me explain what this code is doing, right? It might look complicated right now, but trust me, it's very simple. So this is our Bedrock client invoke with response stream. This is our request. And then from here, until here, we're basically providing a implementation of a invoke model with response handler. This handler is going to register and start listening for whatever changes are coming from the established connection with the foundation model, ultimately with Amazon Bedrock. So we're going to create using the builder. And then there is 3 callback methods that you have to be aware of. The first one is called onResponse. What is onResponse? By the time the connection is actually established and the foundation model is going to start working on the request, it's going to reply back on this onResponse. So this is the indication of, okay, the business has been started, so we can start like working on the request. So I'm just going to print response here, and then the actual processing that we're going to do for the events, you're going to call here on the subscriber, and then you are going to basically provide this implementation of what we call a response handler visitor, right? So in the visitor, you're basically going to implement this callback called visit chunk. So a chunk is a little part of the entire payload that is supposed to be returned by the foundation model. So it's going to deliver you in little chunks, right? So for each chunk, as the name calls, it's going to call this method visit chunk and provide the payload part or chunk, if you will. So your job here is basically to retrieve the payload as a string, but again, remember that is just a part of the entire response. And then, just like we did before, we're going to read it as a JSON payload, and then we're going to print this. And mind that we're going to actually retrieve the completion of this, because we're still using the same foundation model, which is the Anthropic Claude V2. So the structure of the returned JSON is the same. And then the last callback is called onComplete, as the name implies. When the entire response has been provided to the user, is going to call back this method complete, which is your signal that, all right, I'm done. And then you can finish your transaction on your client side. So for our purposes here, what we're going to use is this callback to count down our latch, which is going to signify to our countdown over here, our latch that we've created, that is only expecting one task, by the way, that, all right, this task have finished it. So whatever the JVM was waiting to finish the entire execution, you can follow up on that. So this is the code. Let's execute to see how the response is going to look like. The response is probably going to be the same, but the way the response is going to be provided is going to be in a streaming and continuous fashion. So I'm going to execute this code, and let's see how this goes. So the first thing we're going to see is that response established, and here is the kind of as the response is generated, is we are printing the chunks of each of the response. So that's why it's called the streaming API, because it gives you the entire response in multiple chunks, and you can necessarily have to kind of keep waiting until the entire transaction finishes. So that's why we call this asynchronous programming model. All right, I just showed you how to get started with Amazon Bedrock using Java. Now, I would like to invite you to try things by yourself. With your AWS account, go to the Amazon Bedrock service and enable one or multiple foundation models to play with. Then, use the code that I've provided in the description below to start off your own projects. For any questions about this code, please reach out on X or LinkedIn, and I'll be happy to assist you. If you enjoy watching this video, please smash that like button below. Also, in the event of you wanting to know more about things such as what I've just showed you, please consider subscribe to this channel and enable the notifications button. See you next time.